All right, so the last figure we'll calculate the volume for is a sphere. You all know what a sphere is, right?
Yeah.
We got one more thing after this, but it's not so much volume, okay? So volume of a sphere, okay? It's a slightly different formula than you're used to. I'm not going to go through and derive the formula, you know, well, we got the 1/3, you know, stuff for the pyramids and cones, okay? But the formula for the volume of the sphere is right here, okay? Volume of the sphere equals 4/3 pi r cubed. Everybody see the r here is cubed. It's a real common mistake because you're so used to squaring the r, okay? When you go to a sphere, you'll just, out of force of habit, do 4/3 pi r squared on your, you might even write cubed on your paper or do squared on a calculator, okay? But it is cubed. It has to be cubed, right? Because there's no other, like in the cylinder, right? You got r squared and then a height dimension, which gives you cubic, right? Okay, or in a prism, you got length times width times height. It gives you 3 multiplications to get a cubic unit, okay? There's only one measurement in a sphere that gives us the volume, that's the radius. So to get cubic measurements, we have to cube that one measurement. Does that make sense? Okay? There's nothing else there to make it cube. Now, okay, now they also give you this here. And you probably learned this SA or surface area of a sphere back in 5th or 6th grade, maybe. Are you still doing that then? Okay. They give you that there. So you know the problem we did earlier this morning where there was a candle and they didn't give you the radius to get the volume, but they gave you the circumference, right? Which is in the formula for circumference, you get an R in it and you set them equal and solve the radius. So this will work kind of the same way. So you might see one where they give you the surface area of the sphere is whatever, find the volume. Well, you'll need to find the radius, right? You'll say whatever their surface area is equals 4 pi r squared to solve for that. Does that make sense? So it's a lot like when they gave you circumference instead of radius, all right? Well, so here's some examples. Radius is 3. That's all you need to know. 4/3 pi times 3 cubed, okay? Well, let's see. What is 3 cubed? So it's 4/3 pi times 9. What's 9 divided by 3? 3 times 4? Well, oh, wait a minute. What did I say? Times 12? Okay. Oh, 3 cubed. Look what I did. Look what I did. Did I tell you? Right? It can happen to the smartest person on the planet. It can happen to you. I don't know if it happened to that person or not, but it's possible. Okay? So what is 3 cubed? 3 times 3 is 27. Yes. Boy, that's easy to do. What's 27 divided by 3? 9 times 4. 36 pi. Okay, you don't even need a calculator, right? Over here, radius is what? 5? And we better cube that 5. What's 5 cubed? 120. Boy, look at you. Johnny on the spot, right? Okay, so 125, and it's not divisible by 3, so we can just leave it as 500 over 3 pi. Okay? And if you divide an integer by 3, you know, you get that 0.33333 wherever you cut that off. It's not exact. Okay? Okay, so, oh, and by the way, is this the one where they gave you the, oh, this is another one. Yeah, so they gave you the surface area was 36 pi. I guess this is, yeah, that's a different example, okay? And they want the volume of it, okay? So you said that, I would have put this over here, but anyway, you work that out, you get r squared is 9, so the radius is 3, then you can go and plug it in, okay? Now, that's for a full sphere. For a hemisphere, we don't say semi-sphere, we call it hemisphere. It's half a sphere. And they tried to work out a separate formula for half a sphere. I wouldn't try to remember that, right? So all you really need to do is take the formula for a sphere and multiply it by what? 1/2. Just real quick, just because I know you guys are struggle with this. What's 1/2 times 4/3, guys? What's 1 times 4 over 2 times 3 6, and let's put that in lowest terms. 2/3, okay? So really, that's all you have to do for a hemisphere. You don't have to remember a new formula, okay? Just put 1/2 in front of the 4/3 and do your calculations, okay? All right, let's go down and look at some examples here. I guess these are for you to do. So I want you all to take a minute or two and find the volumes of these figures. Some of them are composite figures, okay? All right. Car engine people, right? Tyler, you ever heard of a Hemi engine? Hemi? Dodge? Hemi? Yeah? What do they call the Hemi? Got something to do with the hemisphere, maybe? The cylinder, the combustion chamber on top of the cylinder is the hemisphere. It's a much more efficient way of getting the explosion to direct itself at the piston. Technically, it's not so, like, when they redid the Hemi about 15 years ago, maybe almost 20 years ago now, so it was a big thing back in the 60s, and they had to get rid of it because of the emissions, and they brought it back. It's not a true hemisphere now. They had to tweak it to meet emissions, I guess. So it's same concept. What do we get for number 1? Pi. Right? So they give you the radius, so volume is 4/3 pi times 12 cubed. Okay? It's going to be a pretty big number, right? So volume equals 4/3. That comes out to what? 1728 times 1728 pi. And you can just divide that by 3, multiply it by 4, or multiply by 4, then divide by 3, whatever blows your hair back. You get 2304 pi cubic centimeters. All right. We get the second one yet?
Yeah.
What'd you get? Ooh, we're all over the place.
504.
We are all over the place. Well, let's find out. Let's see whose monkey's going to make it to the mission here. So we have a hemisphere, right? Half a sphere, which is called a hemisphere. Yeah, it is. We just said this. Right, yeah, that's what you do for hemisphere. Yes, exactly. So some of your calculation got a little kooky there, somebody's calculation. So we're going to do the cylinder.
Oh, there's a cylinder.
What it's on the bottom. Yeah, plus the hemisphere.
Why they design those spheres.
All right, so this is 6, right? The height of the cylinder. You're assuming the radii are the same, right? So volume is going to be, let's do the cylinder, 1/2 of 4/3 pi times 6 cubed. Maybe you didn't cube. So yeah. Okay. Okay. She cubed. You didn't? Oh, I thought you said you did. Okay. Oh, I'm doing, okay, I got this switched. Anyway, just so there's no confusion if you look at that again. I'm doing the hemisphere, right? First, plus the cylinder. Okay, so plus, what's the formula for the volume of the cylinder? Pi times
IR squared.
6 squared times 6. Okay? So you get 216 pi plus 144 pi. What'd you say, Ty? 360 pi. You go down to, like, you guys that were getting different numbers.
I got it right now. I forgot to do the cylinder.
So, well, you got the 216, is that what you said before?
I got 144. He did the hemisphere. Yeah, I got 144.
Well, then you got the cylinder, not the.
Really?
Yeah.
No, I think I just did something wrong.
Yes.
For the second one, it says the volume can not including the tennis balls.
Yes.
So do we have to find the tennis balls
Well, if you're going to not include them,
to know?
you'll have to. What are you going to do there? for number 3. Yeah, right, yeah. Right, you'll need to get the volume of the cylinder minus 2 tennis balls. Or minus 2 spheres, right? So basically it's going to be cylinder minus 2 spheres. Like, you don't have to do minus 1 sphere minus the other because we're going to be the same, right? So minus 2 times whatever, right? Yeah. Right? Everything recording that. Okay. Anyway, I forgot to hit the record button. For those that are watching this video later, forgot to hit the record button. There's the answer for number 3. Nobody in this class reminds me of anything. Okay. Huh? Probably true enough statement. So if I tell you 4 cubed, you all know what that means, right? 4 times 4 times 4. And what does that give you? 64. Now, on your calculator, I mean, you could do 4 times 4 times 4, right? But there's a little caret button. You ever see that caret button on there? So you could do this on the calculator. 4 caret 3 equals. Everyone do that now. Make sure you get 64. That means 4 to the 3rd power. Basically, your calculator does exponents. Other than a shortcut square one, right? So I get 64. Okay. Now, what undoes? We know what undoes squaring, right? What is that? Square root. What undoes cubing then? Cube root. Not square. Cube root. Okay. So we have to change what's called the index here. Okay. So for cube root, bless you. Okay. Let's say I have x cubed, and I want to solve for x. Right. I need to take the cube root. So that would look like this. Okay, notice I have a 3 there in the index of that radical. That means the cube root of x cubed. And what do you think that would equal? Just x, right? Now another way to present this is with exponents instead of the radical symbol. Hopefully you remember this a little bit from algebra, okay? So if I have x to the 3rd, and I want to undo that exponent of 3, I could do the following. To the 1/3 power, that's a cube root. Okay, so 1/3 power is a cube root. The square root would be what power? 1/2, right? A 5th root would be what power if you had to? 1/5, right, in the exponent, okay? So this would also equal x, okay? So we're going to use a power for cube root, right? And on your calculator, I showed you the button that does powers, right? That's a caret upside down V looking thing, right? Okay. What if I had, I even did that. So what's the cube root of 4 cubed, everybody? 4. I could also write this as 4 cubed to the what power? Right? Because hopefully you learned that a power to a power, you multiply the exponents here, right? 3 times 1/3 is what? 1. And 4 to the 1st is just 4, right? Okay? So that equals 4 as well. So let's try a slightly different one. What would be the cube root, because we did it up here, of 64? 4, right? Because we cubed 4 to get there, didn't we? Equals 4. Okay? But also, if we did 64 to the 1/3, would we also not get 4 to the 1/3 power? Right? Now, how do we do that on the calculator? Here's what you'll enter on the calculator. Be careful, okay? 64, caret button, and this is important. Parentheses, 1 divided by 3. I need to put that in parentheses so that whole 1/3, 1 divided by 3, is intended to be in the exponent. Everyone try that right now.
I didn't put it in parentheses.
Does it have to go
Well,
like?
it's because PennDOS does the exponents first, so we do that.
Oh, get the, no, God, you're still using the ABC button, that's why. I know, well, I know, it's not, it's stupid, no.
ABC buttons are like.
A fraction is division, not ABC anything. I want you to think clearly about this. Don't use the ABC button. Ah,
So you use the ABC.
sure, Thomas. Do parentheses 1 divided by, division button. Now did it come out right? All right, hey. Do it this way, the way I have it. Now do it without parentheses. Tell me what you get.
21.3, so.
That ain't right, is it? Right? Okay. Look. The way they teach you to do fractions. I want to put a hot knife in my eye. You come in here, you got no concept, right? So we gotta struggle with fractions. You see a fraction, you guys, you pee yourselves. I'm recording, aren't I? Hold on, I'm not done. So we are all able to get 4 here, right? Let's do one more example. Make sure you can do this correctly. Okay, let's try the cube root. Now you can probably do this in your head without touching your calculator. Somebody just give me the cube root of 27. 3, isn't it?
Ah.
It's what number times itself 3 times? 3 times 3 is 9, 3 is 27, right? 3. But in exponential form, whoops, nope. 3, oh, I did it again. About 27 to the 1/3, right? Would also equal 3. But on our calculator, how are we going to put that in? 27 caret what? 1 divided by 3. Do that now. Verify that you get 3.
You can also just hit the second button. Do it that way.
Yeah? How much self-respect do you have? So, you come with that whole process. You want to know, man. It's like you guys think math is just a series of things to memorize and figure out how to do on a calculator. It's not math.
It is, sir.
It's not math.
It's a form of math.
So that's how you do it on the calculator, class. Right. Let's move on now to the Regents' questions. Okay. Let's look at our first one. So volume of a hemisphere, diameter 12.6. This should be pretty straightforward. We're not going to get through all of them. We'll skip a couple here. Let's see. They gave you the diameter, so of course we need the what?
Radius.
Yes. What's the radius equal? 6.3. All right, this is just basic plug and chug, right? Oh, except that it's not a sphere, it's a what? So volume equals 1/2 times 4/3 times 6.3 cubed.
Now I'm finishing it off.
So hold again. You should bring a purple. What'd you guys get? You mean 523.7? Oh, I forgot the pi. Yep, pi has to go in there.
I forget.
Yeah, I don't want to put it down there because that's incorrect, right? So yeah, I see this on your test. Some of you guys do. You'll have like, when you want to multiply 4/3 by pi, put the pi down there. No. It goes, up. Oh, 4/3 pi times 6.3 cubed. What did we say? It was 523.7 cubic centimeters, which is how to get what out of what? Yeah, so I'm going to do parentheses 1 divided by 2, close parentheses, times parentheses 4 divided by 3, right? Pi times 6.3 to the third power. And I got 523.7. I put 1 divided by 2 in parentheses times 4 divided by 3 with actual division. Okay? Get that to work out?
Yeah.
All right. Let's move on to the next one. We'll have to do a little bit of unit conversion here, right? She got choice 4, 3.81. Who agrees with her? Not him. Well, that's only one kid.
That's only trying.
What they get you down, it's one kid. Trent, what'd you get?
I got number 3.
How many agree with choice 3? He's not done yet. I'll give you all a minute.
Peer pressure.
Well, the correct answer is in fact choice 2.
See, cash.
Yeah. So we need the volume, right? Which of course means we need the radius. Okay, so go to the diameter 1.6.
You get 80.84.
You're getting 12.9555.
0.84. Just copy this. I like scribbled this in it. Somehow I have 8.4. I might have just actually wrote that and got the right answer. Did you get 2.4827 for the volume?
Yeah. Yeah.
I just wrote it right. Somehow I wrote 8.4 in my notes. But anyway, so the radius is 0.84. So our volume, and it's a golf ball, so it's a full sphere, is 4/3 pi times 0.84 cubed. And that should be 2.4827. But now, okay, those who got choice 2, what did the problem ask you to find? Oh,
I multiplied by.
the weight. You multiplied
I multiplied or divided by.
0.65.
0.6523.
So you were kind of confused whether you multiply or divide.
I got 2.
I tried.
Well, obviously.
Perhaps you should have multiplied.
Yeah.
Let's think of it in 2 ways. Let's try and think of it intuitively, right? It says material weighs 0.6523 ounces for every cubic inch. How many cubic inches do you have? This many, and every one of them weighs that, so you'd multiply. Okay, remember, you can't think, right? So this is inches cubed, right? So let's do our unit conversion. We want to cancel cubic inches, don't we? So 2.4827 cubed, inches cubed. What are we going to multiply it by? What ratio? Ounces over inches or inches over ounces? What do I want to cancel? So what goes on the bottom? Okay. For 1 cubic inch. And on top goes 0.6523 ounces. So now what cancels? Cubic inches, right? You guys starting to see how that'll help you, right? Because you can get confused about whether to multiply or divide, right? Easily. And this just, once you put it into a setup like this, it just happens naturally, the right way. And so you should get, where was it, 54, or not, no, 1.619. And the units that are left are ounces. So, got it? So try and use that unit conversion I taught you, right? It'll help keep you from having to see intuitively whether you multiply or divide. Let's pass on number 3 for now. And let's go to number 4. Now he's making a lawn ornament. Like a productive use of someone's day. So let's see, we're going to have radius. Okay, they gave us the radius, right? So the volume, we need to find first before we find the weight. 4/3 pi times 4 cubed. Yeah, okay. Which equals 268.08 268.08 cubic inches. Then, of course, they tell us it weighs 0.0, maybe somebody forgot a zero in there.
That's right.
Yeah, that can happen, 0.075, right? Pound per cubic inch. So we're gonna take this, 268.08 inches cubed, and multiply it by what ratio? What over what? I don't know how that answers my question.
0.75.
That's exactly what we're gonna do, 0.075 lbs over 1 3". Okay? And now we know that these cancel, and we multiply them. We should get 20.1 pounds, because that's the only unit left, right? So 20. Okay? Hey, you're going to get another chance to do your unit conversion in the next one. All right, so move on to number 5. Read that over. All right, so it is choice 1. So as usual, we got to find the volume of this hemispherical, right? Diameter is 10, so the radius is 5, right? Yes, I am. Okay, so the volume is going to be half of 4/3 times pi times 5 cubed, right? I don't always have to use parentheses to multiply, right? I use a little dot. Sometimes the dot isn't really conducive to clarity because dot, decimal. But anyway, you got that right? Yeah. So I believe you get what, 261.799? Yeah. Cubic feet.
Yeah,
And now we need to convert those cubic feet to pounds. What do we multiply by? What ratio?
4 pounds of what?
There's no inches in there. Okay. Multiplied by, yes, pounds over inches. So 62. Oh, you see, look what you did to me. Pounds over cubic feet. LBS over 1 cubic foot. They cancel, and this sets up to tell us to multiply, and you should get 16,336.3. 16,336.3 lbs's. Okay, which is choice 1. Okay, I think we're going to skip over to number 9 and wrap it up with number 9 for now. No, number 9, you might want to draw a sketch of that. And, you know, if you want to draw a really neat sketch, you got a compass in your desk, right? Hey, there you go. So we'll get to use them one more time here. So hollow chocolate spheres. Seems like they could fill the hollow with something, wouldn't they?
yeah,
No.
something like that, yeah.
Anything, peanut butter. Peanut
I
butter.
like peanut butter, yeah.
Definitely not peanut butter.
Roast beef hash.
Why mashed potatoes?
Bacon.
No.
Thanksgiving spirit we talking.
How many do you think you can sit down and eat, Thomas? Let's draw the outside of it, and I'll keep my compass point in the middle there, and I'll just make the smaller. See how nice this works, right? Look at that. I'm going to have a nice diagram here.
That is very nice.
It is nice, yeah. Okay. I mean, I could draw pretty good circles freehand, but then to get one right in the center of the other exactly, it's kind of tough, even though it's nice and round. And I guess I'll label it the way they say. So the big one. Whoopsie daisy.
I'm using a compass and I still can't draw a good circle.
That's kind of amazing. So that's got a radius of 4. And now the sphere, chalk is 0.5 centimeters, right? So isn't that this outer layer? So what's the radius of the hollow part inside?
3.5.
3.5. So what do you think we're going to do here? To get the song chalk? No, the radius isn't 0.5, right? The thickness of the candy, like the shell of it, is 0.6. Well, so the entire radius of the whole thing is 4. The thickness of the outside is 0.5. So the radius of the hollow part is the 4 minus 0.5, right? Okay. So now you have your two radii. So what are we going to do here to get the volume of the chocolate alone?
At least add and subtract.
Well, I don't know what we're going to add, but what are we going to do exactly? Subtract what?
Bigger.
What? Say again?
Smaller one from the bigger one.
Yeah, the whole thing from the hollow core, right? All right. So the big one would be 4/3 pi times its radius cubed minus the hollow part, 4/3 pi times its radius cubed. Let's put all that in the calculator. What do we get? And round it correctly.
Parentheses. 4 divided by 3.
So the whole radius is 4.
What's the diameter?
Let's see.
This is a large diameter.
Oh, the diameter of each sphere is 4. Oh, maybe we got something, okay, we might need to revise this then, huh?
Nah. We're good. I think it looks good.
What? Okay. All right. I think we have a little problem here with my setup.
What's the answer?
I don't know now.
No, on the book.
Well, it's my book. I did it this way.
I got 447.6. That is put the entire thing in. 0.7.
We got to change the radius here. We have to make a change here. So it does say the larger diameter is 4. I want to look at this and make sure I didn't put 4 to 5. Yeah. So this is 4, not 4. What is this? What is it?
2.
2. And so what's the smaller diameter?
1.1%.
Okay, so let's fix it up now. So that's going to be 2, and that's going to be 1.5. All right, so that'll be 2 cubed and 1.5 cubed. And now I should probably recap. You know what's funny? If I get the same answer that I had in my book with this, that means I just miscopied stuff and got the right answer. All right, so 4 divided by 3 times pi times 8.
19.3731. I got 47.6.
Why not go into 0.999?
Minus 4 divided by 3 times pi times, oops, that's not pi, that's a different symbol, we got a pi, times 1.5 to the third. 14.137 minus 33. 19.4.
Yes.
There we go.
I put the entire thing in my gun. Same.
19.4 cubic centimeters. Yeah, that's fine, Trent. I'm fine with that too. Like I said, there's certain steps we can skip at this level, but then sometimes I'll leave it out. Just, when you go back and look at it again, where did you get that? Okay. All right, 19.4.
I'd still work.
Yes, Nikes. Sideways there. All right, let's go to the second part of it. careful, read this carefully here. How many of these go in a box?
8.
8 of them. So our volume that we use is not going to be 19.4, right? What's it gonna be?
155.2.
I got 203.
What?
Yeah.
Over the whole thing.
Yeah.
Yeah, I just want, yeah, well, 8 times 19.4. What the heck?
No, he got, that's his full answers.
Yeah.
Yeah, okay. 155.2.
I got 203.0. Yeah.
Okay. Cubic centimeters. And now we're gonna do our unit conversion, right? We need to convert cubic centimeters to grams. We have a ratio here, don't we? So 155.2 multiplied by what over what, guys? 155.2, just to be clear. Cubic centimeters times what over what?
1.308 grams.
Yep,
1 cent.
cubic centimeter, right? And then they cancel, right? And what do we get?
200.
203
Yeah.
to the nearest gram, right?
Okay.
Everybody agrees 203? 203 grams. Okay. That's the last one we'll do for now. Hmm? All right, so I'll give you your problem set, I'll let you go take a break, come back and do that. And then the last section of this book is just, it's quick, it's not long, okay? So, let's see, for the problem set, it's gonna be all of them,
Yay.
'cause there's not many.
I love that. It's my favorite Christmas gift. All from